This ebook is brought to you by Egenvard 1998. What is a theory? The word theory has the dubious distinction of being one of the most misused and misunderstood words in the English language. Some people contrast theory to truth or fact, but such an antithesis demonstrates a fundamental lack of understanding of all three terms. In science, theories are tools used to generate research and organize observations, but neither truth nor fact has a place in a scientific terminology. Theory defined. A scientific theory is a set of related assumptions that allows scientists to use logical deductive reasoning to formulate testable hypotheses. This definition needs further explanation. First, a theory is a set of assumptions. A single assumption can never fill all the requirements of an adequate theory. A single assumption, for example, could not serve to integrate several observations, something a useful theory should do. Second, a theory is a set of related assumptions. Isolated assumptions can neither generate meaningful hypotheses nor possess internal consistency. A third key word in the definition is assumptions. The components of a theory are not proven facts in the sense that their validity has been absolutely established. They are, however, accepted as if they were true. This is a practical step, taken so that scientists can conduct useful research, the results of which continue to build and reshape the original theory. Fourth, logical deductive reasoning is used by the researcher to formulate hypotheses. The tenets of a theory must be stated with sufficient precision and logical consistency to permit scientists to deduce clearly stated hypotheses. The hypotheses are not components of the theory, but flow from it. It is the job of an imaginative scientist to begin with the general theory and, through deductive reasoning, arrive at a particular hypothesis that can be tested. If the general theoretical propositions are illogical, they remain sterile and incapable of generating hypotheses. Moreover, if a researcher uses faulty logic in deducing hypotheses, the resulting research will be meaningless and will make no contribution to the ongoing process of theory construction. The final part of the definition includes the qualifier testable. Unless a hypothesis can be tested in some way, it is worthless. The hypothesis need not be tested immediately, but it must suggest the possibility that scientists in the future might develop the necessary means to test it. Theory and its relatives. People sometimes confuse theory with philosophy, or speculation, or hypothesis, or taxonomy. Although theory is related to each of these concepts, it is not the same as any of them. Philosophy. First, theory is related to philosophy, but it is a much narrower term. Philosophy means love of wisdom, and philosophers are people who pursue wisdom through thinking and reasoning. Philosophers are not scientists, they do not ordinarily conduct controlled studies in their pursuit of wisdom. Philosophy encompasses several branches, one of which is epistemology, or the nature of knowledge. Theory relates most closely to this branch of philosophy, because it is a tool used by scientists in their pursuit of knowledge. Theories do not deal with oughts and shoulds. Therefore, a set of principles about how one should live one's life cannot be a theory. Such principles involve values and are the proper concern of philosophy. Although theories are not free of values, they are built on scientific evidence that has been obtained in a relatively unbiased fashion. Thus, there are no theories on why society should help homeless people or on what constitutes great art. Philosophy deals with what ought to be or what should be, theory does not. Theory deals with broad sets of if-then statements, but the goodness or badness of the outcomes of these statements is beyond the realm of theory. For example, a theory might tell us that if children are brought up in isolation, completely separated from human contact, then they will not develop human language, exhibit parenting behavior, and so on. But this statement says nothing about the morality of such a method of child rearing. Speculation. Second, theories rely on speculation, but they are much more than mere armchair speculation. They do not flow forth from the mind of a great thinker isolated from empirical observations. They are closely tied to empirically gathered data and to science. What is the relationship between theory and science? Science is the branch of study concerned with observation and classification of data and with the verification of general laws through the testing of hypotheses. Theories are useful tools employed by scientists to give meaning and organization to observations. In addition, theories provide fertile ground for producing testable hypotheses. Without some kind of theory to hold observations together and to point to directions of possible research, science would be greatly handicapped. Theories are not useless fantasies fabricated by impractical scholars fearful of soiling their hands in the machinery of scientific investigation. In fact, theories themselves are quite practical and are essential to the advancement of any science. Speculation and empirical observation are the two essential cornerstones of theory building, but speculation must not run rampantly in advance of controlled observation. Hypothesis. Although theory is a narrower concept than philosophy, it is a broader term than hypothesis. A good theory is capable of generating many hypotheses. A hypothesis is an educated guess or prediction specific enough for its validity to be tested through the use of the scientific method. A theory is too general to lend itself to direct verification, but a single comprehensive theory is capable of generating thousands of hypotheses. Hypotheses, then, are more specific than the theories that give them birth. The offspring, however, should not be constant with the parent. Of course, a close relationship exists between a theory and a hypothesis. Using deductive reasoning, going from the general to the specific, a scientific investigator can derive testable hypotheses from a useful theory and then test these hypotheses. The results of these tests, whether they support or contradict the hypotheses, feed back into the theory. Using inductive reasoning, going from the specific to the general, the investigator then alters the theory to reflect these results. As the theory grows and changes, other hypotheses can be drawn from it, and when tested they in turn reshape the theory. Taxonomy. A taxonomy is a classification of things according to their natural relationships. Taxonomies are essential to the development of a science because without classification of data science could not grow. Mere classification, however, does not constitute a theory. However, taxonomies can evolve into theories when they begin to generate testable hypotheses and to explain research findings. For example, Robert McRae and Paul Costa began their research by classifying people into 5 stable personality traits. Eventually, this research on the Big Five taxonomy led to more than a mere classification. It became a theory, capable of suggesting hypotheses and offering explanations for research results. Why different theories? If theories of personality are truly scientific, why do we have so many different ones? Alternate theories exist because the very nature of a theory allows the theorist to make speculations from a particular point of view. Theorists must be as objective as possible when gathering data, but their decisions as to what data are collected and how these data are interpreted are personal ones. Theories are not immutable laws, they are built, not on proven facts, but on assumptions that are subject to individual interpretation. All theories are a reflection of their authors' personal backgrounds, childhood experiences, philosophy of life, interpersonal relationships, and unique manner of looking at the world. Because observations are colored by the individual observer's frame of reference, it follows that there may be many diverse theories. Nevertheless, divergent theories can be useful. The usefulness of a theory does not depend on its common sense value or on its agreement with other theories, rather it depends on its ability to generate research and to explain research data and other observations. Theorists' personalities and their theories of personality. Because personality theories grow from theorists' own personalities, a study of those personalities is appropriate. In recent years, a subdiscipline of psychology called psychology of science has begun to look at personal traits of scientists. The psychology of science studies both science and the behavior of scientists, that is, it investigates the impact of an individual scientist's psychological processes and personal characteristics on the development of her or his scientific theories and research. In other words, The psychology of science examines how scientists' personalities, cognitive processes, developmental histories, and social experience affect the kind of science they conduct and the theories they create. Indeed, a number of investigators have demonstrated that personality differences influence one's theoretical orientation as well as one's inclination to lean toward the hard or soft side of a discipline. An understanding of theories of personality rests on information regarding the historical, social, and psychological worlds of each theorist at the time of his or her theorizing. Because we believe that personality theories reflect the theorist's personality, we have included a substantial amount of biographical information on each major theorist. Indeed, personality differences among theorists account for fundamental disagreements between those who lean toward the quantitative side of psychology and those inclined toward the clinical and qualitative side of psychology, psychoanalysts, humanists, and existentialists. Although a theorist's personality partially shapes his or her theory, it should not be the sole determinant of that theory. Likewise, your acceptance of one or another theory should not rest only on your personal values and predilections. When evaluating and choosing a theory, you should acknowledge the impact of the theorist's personal history on the theory, but you should ultimately evaluate it on the basis of scientific criteria that are independent of that personal history. Some observers have distinguished between science as process and science as product. The scientific process may be influenced by the personal characteristics of the scientist, but the ultimate usefulness of the scientific product is and must be evaluated independently of the process. Thus, your evaluation of each of the theories presented in this book should rest more on objective criteria than on your subjective likes and dislikes.